Okay, we're going over factoring quadratics. This is a quadratic expression in standard form. When we're factoring, our main goal is essentially to go from standard form to factored form. If you guys recall, our standard form, and of course this should say y equals, standard form is ax squared plus bx plus c. Okay? This is our a, this is our b, and this is our c. Okay? So we need to be able to determine what is what. Our a term is our 6, our b term is our negative 14, and our c term is our negative 12. As you guys learned the other day, with factoring, you did learn a shortcut when the a value was 1. Okay? But today we're working on when a value is not 1. So we're going to go back to that original method we learned, where we find the factors of a and the factors of c. This will work for almost any trinomial quadratic to factor. So we look for the factors of 6. Well, factors of, 6m are 6m and 1m and 2m and 3m. Okay? So what we now have are two columns to test out to see which will be the first terms. Okay? And with our second terms, well, we have to look for factors of 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay? And again, we set them up into columns so that we know that we don't use the wrong numbers. The order top or bottom doesn't matter because we're going to be testing straight across and diagonally. Okay, and you'll see what I mean in a minute. Our goal is to find the products of two columns that are going to add up to what our b term is, or our middle term. Our middle term in this case being negative 14m. Now, technically, what is the first step to all factoring? Anyone remember? Does anyone know what the very first type of factoring we should do is? Even though I set this all up, I should have done something beforehand. Starts with C. Common factoring. Is there a common factor in this? Yes. We can take 2 out of all of these terms. Okay? What I'm going to do is I'm going to factor it this way, and then I'm going to show you how common factoring would have made this a simpler question. And when a question asks you to fully factor, that means you must common factor first if there's an option, and then factor. Okay? So, again, let's try this out. So we go through our columns, 6 and 1. Well, we're going to test these out. 6 times 1 and 1 times 12 will give us 6 and 12. Any combination of 6 and 12 make 14. Can you add? No. Answer's no. Stay with me, okay? We can then try diagonally 1 by 1 and 6 by 12, which will give us 1 and 72. Any combination of that make 14. No. Okay? So, we know the first column doesn't work for 6 and 1, but we don't know if 6 and 1 is even the correct column. So we're not going to cross it out yet. We're just going to keep going through the other ones. 6 and 2 and 1 and 6, that's going to give us 12 and 6. Any combination 14? Nope. Then we go across 6 by 6 and 1 by 2. That'll give us 12 and 2. Any combination of that make 14? Yes. So let's make sure this is the right type of combination, because we may find more than one combination, but only one set will be correct. If I go 1 by 2 and, oh, sorry, is that the right one? Nope, sorry. 6 by 2 and 1 by 6, that gives us 12. What did I do there? Did I do the mathematics wrong? Oh, sorry. 6 times 6 is 36. Thank you. Good. So I did make an error there, too. Any combination of that work? No. Okay. I added instead of multiply. So we know this column doesn't work for us. Either does the first one. Let's go to the third. 6 by 3 and 1 by 4. That gives us 18 and 4. Any combination of that work? Yes. Yeah, a combination of that will work. Like I said before, we got to test to see. So 6 by 3 and 1 by 4. We're going to get 18 and 4. What has to be positive? What has to be negative in order for this to work? The 4 is going to need to be a negative number, okay? Which means when I multiply this 1 by this 4, I need to make this 4 negative. And 6 by 3, well, the 3's got to be positive to get positive 18. Now, this is our test. Is positive 3 times negative 4 equal negative 12? Yes. Yes. In some cases, what you're going to find out when you apply the negative, you won't get the same factor up here, and that won't work. In this case, it did work. So that's going to be our permanent answer. We know that, so I'm going to write it in permanent ink here. We're multiplying 6 by 3 to get 18, and 1 by 4 to get 4. We're going to turn this 4 into a negative, because technically, we can't use positive 3 and positive 4 to get negative 12. One of them needed to be negative. Oh, yeah, you're right. Thank goodness. Thank goodness Everett's here, guys. He's the only one who should be teaching this lesson. So, that's okay. We just got to move the negative up. Okay? Sorry, so the 3 needs to be the negative, and the 4 needs to be the positive. Okay, in this case, in order for this to add up to negative 14. So we have our correct terms. We can now move into our factored form. Because we know we're using this set here, 6m is going to go into 1, and 1m, or just m, will go in the other. Now, this is what I was talking about the other day. Because I multiplied the 6 by the negative 3, they have to go in opposite columns. So the 6 and the negative 3 need to be in opposite columns. And the 1 and the positive 4, 1m and positive 4, need to go into opposite columns. Otherwise, we've done this incorrectly. Okay? So this is technically our factored form, but I could have factored farther. So, this is our factored form. Remember, I told you we could find a common factor first at the beginning of this. Well, if we look very carefully at this, the m and the 3, that's pretty much as simple as it gets. But what about this 6m and this 4, just this column here? Is there a common factor in that? 2. So let's take the 2 out of that. Okay? We can divide this by 2. So even if I don't common factor first, maybe I forget to, I can look at my answer at the end and quickly or briefly check, is there a common factor in that I could have taken out? So I could have taken 2 out as a common factor, which means we can now have 2. This would be left 3m plus 2. And m minus 3. Okay? Whether we common factor first or second. Now, we went through this process in depth. I'm going to quickly common factor first, the exact same answer, and show you how we would have got to the same result, even if we'd common factor first. Only difference is I'm going to go much quicker through this, since we've already done it once. 6m minus 14. So my talking may speed up a little, okay? Common factor is going to be 2, which means we're going to divide all of these by 2, which will then give us y is equal to 2, 3m squared minus 7m minus 6. Now our goal is to only factor the brackets. Well, we're going to get 3m and 1m as factors, 1 and 6, 2 and 3 as factors. We know that their products need to add up to our middle term, which is negative 7. Quickly looking at that, we're probably going to be using 3 and 3, which will give us 9m, and 1m times 2, which will give us 2m. The 9 will need to be negative. In other words, the 3 will need to be negative in this column here. So when we go to put it into factored form, y equals, we still keep the 2 on the outside. In our brackets, one of the answers will be 1m. Okay? And remember, because we multiplied 1m by 2, it goes into the opposite bracket. And 3m and negative 3 goes into the other bracket. So if we extend this page just a little, you'll notice that this answer and this answer are the exact same thing, just the brackets are in different order, which is fine. It doesn't matter what order you put them in due to cumulative property when multiplying. It doesn't matter what we order or so what order we multiply by, it just matters that we do it all correctly. Okay? So whether we common factor first or not, we'll still get the same answer.